Hello everyone. Today I will solve the problem Ferris wheel of CSES problem set. Let's go to the problem statement. There are n children who want to go to a Ferris wheel, and your task is to find a gondola for each child. Gondola in the sense each box of the Ferris wheel we can say gondola. Each gondola may have one or two children in it. Maximum children it can have it's two. Okay, and also the total weight of gondola may not exceed x. So the maximum weight of each gondola may not should not exceed x. Okay, and we are given the weight of every child. So what is the aim of what is our aim? We have to find the minimum number of gondolas needed for the children. Okay, so we are given n, the number of children, x, the maximum allowed weight of each gondola, and the next n array which for which we have like a weight of each child. Okay, so we have to print the minimum number of gondolas. So what will be the like a best like suitable answer? If we have all the suitable condition, then definitely the minimum answer would be n by 2 because we allot two children to each gondola. So answer would be n by 2. But here we have to consider the weight of the children. So some gondolas may have one children in it. Okay, and also okay. So let me so we have let me explain you with this test case. This is the weight of children and we have given the x equals 11. So maximum weight of a gondola can carry is 11. Okay, so what I have given like a maximum weight is 9 and which is h, and l like a minimum weight of a children is 2. Okay, so suppose if I am pairing L with other children other than H, if I am pairing 2 with 7, okay, so what will happen? If I am pairing L with the lowest weight with other children other than the highest weighted children, what will happen? We have to pair H, the highest weighted children, with the child who is greater than L. Okay, did you understand what I am saying? Like if I am pairing L with other children other than H, so if I am pairing 2 with say suppose 7, okay, so what will happen? I have to pair 9, which is highest weighted children, with weight more than L. Here like we have 2 but it will not be the case every time. So we have to pair highest weighted children with weight other than like higher than L, which is lowest weighted children. So there are chances in which the weight will be like overweight H plus some children bigger than X L. Okay, let me write it. If I am pairing L, suppose these are the order A, B, and H. Okay, so A and B are some random middle numbers. L is the lowest one, and H is the highest one. Okay, uh, so suppose if I am pairing L with A, so what does that mean? I have to pair implies that I have to pair H with B, which is some middle element. So what is the problem here? The problem is that uh, there are higher chances that H or B will be overweight. Okay, did you understand? So what if they are overweight? Then we cannot like make them together. We cannot pair them. Okay, So the best thing is to pair the highest weighted children with the lowest weighted children. So that is the safest option for us. Okay, we are playing safely. Okay, so that is my statement. What I have to do, I have to pair the highest weighted children with lowest weighted children and then shrink the array and come together. Okay, so okay, what I am doing, pairing H and pairing H and L. Okay, so what are the condition in this? If H plus L is greater than X. Okay, first condition is like if H sorry H plus L is greater than X. So what does that mean? The H cannot be paired. If it is not pairing with the lowest weighted children, then it cannot be paired with any other children. Okay, so that is H has to sit alone. Has to sit alone. Okay, if H plus L is less than or equals to X, what does that mean? It means that if H plus L is less than or equals to X, that means we can pair both of them. Okay, we can pair both of them. That also implies that we can pair H with some other, like we may pair some other elements other than L. So that also implies, but that you might think uh, L can be used if H plus L, if H can be paired with some other element greater than L, so why should not we save L for some other elements? Okay, so my what I'm saying, if H plus A, it this can also be paired. Okay, so why not save L other element for other elements? So my simple question is, like, my simple statement for this is, like, if H plus A is paired, can be paired, then A can be paired with any element less than H. So that doesn't matter because we have to sit on, like, we have to accommodate only two children maximum. Okay, so that's a very, I think, simple and intuitive as well. If we can, H can be, why, okay, my answer is, like, why not save L for other elements? So that's the simple answer. Okay, because if A can be paired with H, then A can be paired with any other element which is less than H, so A will be paired with that element, so that we don't have to, like, bother about it. Okay, so let me go for the code only now. So what we have, nx and an array. Okay, see, this is my, like, snippet for the code forces contest. So let me remove the t test cases and nxt. Okay, nx. Okay, c in x and vector is v. Okay, so we have taken the input. So what I have to do, int I equals 0, which will point to the L, the lower smaller sides, and int j would point to higher side. Okay, so now we can run the loop while we will discuss about that. Okay, so if we are at I and j, so there will be two cases. Okay, like if v of I plus v of j is less than x, so that can be accommodated. Okay, and gondola plus plus, and we can increase I and we can decrease j. Okay, if suppose if v of I plus v of j is greater than x, here I have to like consider the equal also. If greater than x, then what we should do? So uh, so what we can think is like what does that mean? The v of j, like which is the heavier element, we'll have to set alone. Okay, so we can do j minus minus and gondola plus plus, like we have to increase the gondola. Okay, so okay, and before that we have to like sort it. Like, we dot begin. I am like I was definitely considering of v. Let me write it before. So without sorting, the we cannot get h and like highest and lowest together. So without sorting, there would be two random numbers. So it's very like inefficient to pair them, and it will be very difficult to pair them. Okay, and it will be inefficient also. Okay, so and here what I can write, while I is less than or equals to j. What does that mean? If I and if I is less than or equals to j, what does it mean? Like j, when will it end? Just the moment j becomes less than I. So till when will it run? When till I equals j. Okay. So if I equals j, so we have to consider that. Okay. Uh, so let me run this test case for that. Okay. So our desired output should be 3. Let's see. Okay, okay, I didn't define gondola. So int gondola equals 0, and also I did forgot to print also. Okay, so see out gondola. I think that should be fine. Yeah, yeah. So let me submit as well. Test it. Okay, we are getting a lot of wrong answers. Okay, so let me think of the answers. Okay, I plus plus j minus minus. Okay, and also J minus minus I have done. Gondolas are increasing after every iteration, so like I have done in both, and also these, at least one of these statement will definitely run. So I think that's not the problem. J equals n minus 1. Okay, let me think of that. Actually, okay, so like it's due to my code forces snippet. Like I used to take that input, so let me do this t and also this as t. Okay, and I think that should be fine. tt we have. Okay, let me resubmit it. Okay, now let us see. Okay, yeah. So what did we learn here? Like in this question, like we have to pair like highest and lower, and why we are pairing, because if we are not pairing L with H, so we, that means we have to pair H with some other element which is greater than H, so that can be a problem. Okay, so that's why we are pairing L plus H and shrinking down the array. So like I'm writing the raw code, like I'm not seeing the code, and so that's why I'm getting errors, so that's not the problem. Okay, so that's it from my side.